Hi, welcome to my video on the review of Trig Identities. This review can be done as a quiz, but I decided not to have any marks because it's very hard to give marks for proofs that are done with identities or in geometry. So let's start. Pause the video and work each of these out to see if you get them right. Remember, the questions are in order as they are in the videos on identities. Number one, simplify each. 6 sine plus sine, excuse me, 6 plus 1 is 7, so it's 7 sine theta. You add like terms. And you're subtracting, so you add on the opposite. So 4 cos theta plus 2. Subtracting, so you add on. The opposite of 1 is negative 1. The opposite of a positive cos theta is a negative cos theta. And when you add like terms, 4 minus 1 is 3. You add your cos thetas, and 2 subtract 1 is plus 1. And another way you can do it is put a 1 here and a 1 here and multiply 1 by these two. Will give you these two terms. And a negative 1 times 1 is negative 1. Negative 1 times positive cos theta, negative. So you can put a 1, negative 1 there and multiply. Just another little trick. 2 sine theta times 1 plus sine theta. 2 sine theta times 1 is 2 sine theta. And 2 sine theta times sine theta is a positive. 2 times 1 is 2. Sine theta times sine theta is sine squared theta. And we're multiplying cos squared times 1 over cos squared. We can cancel. That's a 1, so that cancels once. And cos squared divided by cos is cos theta. Cos theta times 1 is cos theta. And we're dividing fractions, so when we divide fractions, the sine over cos multiplied by the reciprocal of your denominator, which is cos theta over 1. And because we're multiplying, we cancel the cos's out, and we get sine theta over 1, or sine theta. And we have to obey PEMDAS. We have to multiply these first before we subtract. So we're multiplying, so cos, we're dividing by cos, multiplying by cos, so they cancel out 1, 1. So we get 12 sine theta, subtract. Sine theta times 1 is sine theta. 12 minus 1 is 11 sine theta, because we can subtract these because they're like terms, sine thetas. Number 2, hopefully everything is going okay. And now we have some fractions and simplify. And when we add fractions, we have a same denominator, which is sine theta, so we write that down. And that's cos plus 1. Cos theta plus 1. They have the same denominator. Again, you write down the sign. And cos theta plus 1, you have to leave them separate because you cannot combine them. And these two fractions have the same denominator, so we write down the denominator of cos theta sine theta, and that's 4 sine theta minus 2 sine theta, which gives us 2 sine theta. And we're dividing, so we cancel out the like factors. Sine is common to the numerator and denominator cancel, so we get 2 over cos theta. And that could become, if you wish, that's 2 times 1 over cos theta. So that could become 2. The reciprocal of cos is secant. So you could have 2 over cos or 2 secant theta. And C, 1 over sine squared, subtract 1 over sine. The common denominator is sine squared, so we multiply the second fraction by sine theta over sine theta. And that's 1 over sine squared theta, subtract. Sine times sine is sine squared. 1 times sine is sine theta. And the same denominator is sine squared. We write it down, and that's 1 minus sine theta. Simplified. And again, this could go further, but we're not worried about changing sine squared. Now we have a common denominator for two fractions. The common denominator, the LCD, is cos theta sine theta. So we multiply this fraction by sine theta over sine theta. And we multiply this one by cos theta over cos theta. And sine theta times 1 is sine theta. Sine times cos stays like that. You can't multiply them, combine them. 1 times cos is cos theta. Sine times cos stays like that. And the two fractions have the same denominators, so we write down that denominator of sine theta cos theta. And sine plus cos, we cannot combine them, just write them down. Sine theta plus cos theta. So, hopefully everything is going okay. And now we have fill in the blank with sine, cos, or sine and cos, or cos and sine. And our name for tan is sine over cos. Remember, sine is opposite over adjacent, and the opposite has sine, and the adjacent has cos. Cot is the reciprocal, so it's cos over sine. Secant is the reciprocal of s. It's got to be a c, so it's cos. Cosecant is the reciprocal 1 over, that's a c, so I need an s, so that's sine. Again, if you have to have these memorized. Number 2, fill in the blanks. Cos squared plus sine squared, 1. 1 minus sine squared, so if you take the sine squared and move it over to the right, you get a minus, so that's cos squared. And 1 minus cos squared, so if we take the cos squared and move it over here and make it a minus, you get sine squared. And 1 plus tan squared, if we got that memorized, tan, let's see, tan is sine over cos. And how I remember it, cos is with the cos, so the reciprocal of cos is secant, so it's secant squared. 1 plus tan squared is secant squared. 1 plus cot squared is cosecant squared. Again, learn these. And another way, cot is cos over cos is adjacent over opposite. Opposite is sine, and the reciprocal of sine is cosecant. That's another way to. So tan is sine over cos. Cos is on the bottom, so I need a reciprocal, which is secant. Cot is cos over sine. Sine is on the bottom, so I need cosecant squared. Again, memorize them. Number 3, simplify each in terms of cos, sine, or cos and sine. So cosecant squared is 1 over sine, so it's 1 over sine squared times sine. And we're multiplying, that's over 1, so we cancel 1 over sine. So that's sine divided by sine is 1. Sine squared divided by sine is sine. So that's 1 over sine. And again, I want it in terms of sine and or cos, so it's 1 over sine. Now you could, this could also be cosecant. Sine, you can see, but I want it in terms of sine or cos or sine and cos. And we have sine, cot is the cos, cos theta over sine theta. Secant is 1 over s. I need a c, so it's cos. And we're multiplying, so that's sine over 1. So the sines cancel. The cos cancels. And I get 1 over 1, which is 1. Remember, tan is sine over cos, so cot is cos over sine. Again, memorize them and everything, because you need to do them when you need to know them readily when you're doing identities. Simplify each in terms of cos, sine, or cos and sine. So we have sine theta, and tan is sine over cos. So that's sine. Notice this is a division here. This is the main division. So that's sine divided by sine over cos. So we multiply by the reciprocal, which is cos over sine. And that's sine over 1. So we're multiplying fractions. We cancel numerator and denominator. So that gives us cos theta. And we have, again, a division. Secant is 1 over cos. Cosecant is 1 over sine. We got two fractions, so we're dividing. So this 1 over cos times the reciprocal, which is sine theta over 1. Reciprocal of 1 over sine theta is sine theta over 1. No cancellation. 1 times sine is sine. Sine theta. Cos theta times 1 is cos theta. And we want it in terms of sine and or cos, so there it is. But if there was a multiple choice, this could also be another name for tan, but we want it in terms of sine and or cos. Here they are. E, we have an addition and a multiplication, so we should change the tan first. Tan is sine over cos. And we should multiply by PEMDAS. We should multiply first before we add, so we cancel these out. So that's 5 sine theta, 4 times sine. Like terms, so 5 plus 4 is 9 sine theta. And F, 1 minus sine squared, is cos squared divided by cos. And again, cos squared divided by cos, that cancels to give me cos theta on the top. Remember, another name for 1 minus sine squared could be 1 minus sine, 1 plus sine, but that won't simplify. So you could have done 1 plus sine times 1 minus sine. But if you did that by factoring, this wouldn't simplify any further. So 1 minus sine squared is cos squared and a cancellation. G, I see 4's common. So it's a GCF of 4. 4 into 4 goes once. 4 into 4 cos squared is cos squared. All over 8 sine theta. Write it down. And I see 1 minus cos squared is sine squared over 8 sine. So 1 minus cos squared is sine squared. And 4 and 4 goes once, 4 and 8 goes 2. Sine to sine goes once, sine to sine squared goes sine. So we have sine theta on the top with a 2 on the bottom, and that could also be 1/2 sine theta. So sine theta divided by 2. Remember, that's a 1 there, or we could have a half sine theta. H, cos squared plus sine squared. I recognize that to be 1 times sine. That's a multiplication, so that gives me sine theta. Cos squared plus sine squared is 1. I, we have to change these. Secant is 1 over cos theta. minus cos. And common denominator is cos, so we multiply this one by cos theta over cos theta. So that's 1 over cos, and 1 times cos. 1 times cos is cos theta. Cos theta times cos theta is cos squared theta. We have two fractions with the same denominator, so we write down that denominator of cos theta. And this is 1 minus cos squared. And 1 minus cos squared is sine squared. And we can't simplify any further. Again, when you do identities, which the left side equals right side, you'll know when to stop. 1 minus cos squared could become a sine squared. So I could do sine squared all over 1 plus cos, but it's not going to simplify any further. So I recognize that this didn't do anything for me. So 1 minus cos squared is 1 cos with a plus and a minus. So that's 1 minus cos theta all over 1 plus cos theta. And because it's factorable, and I noticed that because on the bottom I had 1 plus cos, so then I recognize this is the difference of two squares, 1 plus cos, 1 minus cos. They cancel out, so it's 1 minus cos theta when you simplify it. Again, if you made that sine squared, it didn't simplify any further. So you had to recognize that this is the difference of two squares, and these two factors canceled. And k, I see a cos in both terms, so GCF is cos theta. So that's cos theta divided by cos is 1. Cos cubed divided by cos is cos squared. Remember, you subtract your exponents when you're dividing. 3 subtract 1 is 2. And 1 minus cos squared is sine squared. And we can't simplify it any further. L, 1 plus tan squared, recognize it as secant squared divided by secant. And secant squared divided by secant is secant. And secant is 1 over cos theta. Again, recognizing that 1 plus tan squared is secant squared makes this simple. If not, you would have to go through extra steps, changing tan to sine over cos, changing secant to 1 over cos, and work it out the long way. Okay, simplify each, same again. And we have sine to the fourth minus cos to the fourth. And I recognize that this is 6, this is down on the bottom. So if I take 6 as the GCF on the bottom, I get sine theta minus cos theta. And that's factored. So I recognize fourth. So sine squared cos to the fourth is cos squared theta. That's a plus and a minus, difference of two squares. And if we keep going, that's sine squared plus cos squared is 1. And this is sine squared minus cos squared, so that's sine theta plus cos times sine theta minus cos all over 6 sine theta minus cos. Notice you keep factoring, and sine theta minus cos theta is there, so that as a factor cancels out. So this becomes sine theta plus cos theta divided by 6. or we could have 1/6 sine theta plus cos theta, or we could also have 1/6 sine theta plus 1/6 cos theta. So you could have this, you could have because that's a 1 times understood to be 1/6, or you could put the 1/6 through both terms. Okay, fully simplified. And in, let's see, we have to change tan to sine over cos. Cosecant is 1 over sine. Cot is cos theta over sine theta. Secant is 1 over cos. And we have them changed. Now we're multiplying, so we can multiply two fractions. We got to multiply first before we add. Sines cancel. That gives us 1 over cos. And the cos cancels. When you're multiplying, you cancel. You get 1 over sine. And so that means you multiply, the common denominator is cos and sine. So you multiply this fraction by cos theta over cos theta. And you multiply this fraction by sine theta over sine theta. Sine times 1 is sine. And the denominator is sine theta cos theta. 1 times cos is cos. And that's sine times cos. Just write it down. The two denominators are the same. So we have sine theta is the common denominator. And sine plus cos, we can't add them, so we just write down the sine theta plus cos theta. And that's fully simplified. Hopefully everything is going okay. Trying to do a review to make sure you have a better chance in doing identity when you have quizzes. Now, proof. Proof. When you do proof and identity, you have a left side, which is this one, and you have a right side, which is that one. So the right side is 1. So I have a sine theta, cot theta, cos theta, add on, tan theta, sine theta, cos theta. So that's the left side, and that's the right side. So we have to take one of the sides and work them to the other without work one side down completely. So let's take this side. Looks like the more awkward side, more difficult side. So cot is cos over sine. Cos theta. Tan is sine theta over cos theta. Sine theta, cos theta. So what I did, I changed cot and tan to cos over sine, sine over cos. And again, we're multiplying before we add. So they cancel out 1, 1, and we get cos times cos is cos squared theta. And right here, we're multiplying, so we cancel. Cos cancels, top and bottom. So we get a cos sine squared. Sine times sine is sine squared. And cos squared plus sine squared is 1. Notice I work this down to get a 1, and that's a 1. And what I do is I make a statement. Since the left side equals the right side, it is an identity. Okay, let's continue. Another proof, identity. Again, we have to write down left side, and we have to write down the right side. The left side is secant theta minus tan theta over cosecant theta, and the right side is cot theta sine theta. So the more difficult side to work will be this one. And so let's work the left side. Secant is the reciprocal of cos, is 1 over cos theta. Tan is sine theta over cos. And draw a line. Cosecant is 1 over sine. So I have them all changed in terms of cos and sines. So because this is a division here, and this is a subtraction, I have to simplify this division here. So that's 1 over cos, subtract sine over cos. Because you're dividing fractions, you multiply by the reciprocal at the bottom, which is sine theta over 1. Now we have to multiply before we subtract. So that becomes cos times 1 is cos theta. Sine times sine is sine squared theta. The common denominator is cos, so we write that down. And we have 1 minus sine squared. And 1 minus sine squared is cosecant squared, or sorry, cos squared over cos. And notice we need this, so I can make that, I can cancel those out to make that a cos. So notice I didn't get this. So remember what I told you? To take this, pretend now, write this down on a sheet of scrap paper and work it out. So cot is cos over sine times sine. And notice they cancel out and they give you 1. So if I did it on scrap paper now, remember, you don't see what I'm showing you here. So you look at it and say, oh, that's 1, 1, so that's cos theta. So this becomes cos theta. So what you do, you reverse it. So you take this step right here and you write it here. Then you take this step right here and put it down here. Cos sine is cot. So remember, this is on a sheet of scrap paper that you worked out. So when you do get the same, then you reverse the step. Take that step and put it there. Take that step and put it there. Then remember now, this is not on your, if it was a quiz, this is not. You don't see this at all because it's done on a sheet of scrap paper. So the left side is the right side. So since the left side equals the right side, it is an identity. And again, I worked this side completely to get that. And that's the way, check with your teacher. That's what you have to do. Number 6, proof again. We have to have a left side, which is sine theta minus cos squared sine. And we have a right side, which is sine cubed. So I look around and I say, this is easier. So I got to change this side to this. But notice that the right side is sine. That means cos has to go. So one way to do that is one way is to factor the sine out. So if I factor the sine out, I get 1 minus cos squared. Well, that's cos theta there. So I see sine as common, so I take the sine out, and that's sine. 1 minus cos squared is sine squared. And sine times sine squared is sine cubed. So, since the left side equals the right side, it is an identity. But there's also another way that we could handle that. Just let me show you. This side has a sign, so if you factored out the sign like I did and worked it through, perfect. But also, you notice that this side got sine, this side got sine and cos, so you could have changed your cos squared to 1 minus sine squared. And now, since if you did that, you minus sine times 1, the negative, so pretend that that's a negative sine times 1, so it's a negative sine, and a negative sine times the negative is a positive sine cubed. They cancel out, and you get the sine cubed. You could have done that. Again, I want to show you this right here. That's sine, and if you move the sine theta to the left of the bracket like this, this is the same as this. I just moved the sign in front, and now you can see that negative sine times 1 is negative sine, and a negative sine times a negative sine squared is a positive sine cubed. So again, either or, whichever way you do it. And number 7, the last one to do. Again, we have a left side, which is 1 over 1 minus cos. Subtract 1 over 1 plus cos. And the right side is 2 cot theta cosecant theta. And the harder one, looks like the more awkward one, is the left side. Let's take this side and change it to this side. We have a common denominator, and that means we multiply. We can take this fraction. The common denominator is 1 minus sine times 1 plus sine. So we take multiply by 1 minus. So by saying sine, this is 1 over 1 minus cos, 1 over 1 plus cos. So the common denominator is that I have to take the two of these to be the common denominator. So I multiply 1 plus cos again. This denominator, they're different, so you multiply this one by 1 plus cos over 1 plus cos. You multiply this one by 1 minus cos over 1 minus cos, and that gives you 1 plus cos times 1. There it is. And the common denominator is 1 plus cos theta, 1 minus cos theta. And 1 times 1 minus cos is 1 minus cos theta, all over 1 plus cos, 1 minus cos. And we're subtracting, so we add on the opposite, so we can this is more writing down than takes time. So we're subtracting, so we add on the opposite, which is a negative 1 plus cos theta. Because when you subtract, you make that a negative, you make that a positive, so we're adding on the opposite of the numerator, which we have done. Now the two denominators are the same, so we write down 1 plus cos, 1 minus cos, that's the common denominator. So 1 add on -1 cancels out, and we got cos plus cos is 2 cos. And now we're stuck. So what do? Again, we go to this side. Pretend you're on a sheet of scrap paper. So you go over and say, this is 2. Cot is cos theta over sine theta. Secant is 1 over sine. And that's 2 over 1, so that's 2 cos theta all over sine squared. Okay, you look over here and you say, that's 2 cos, and that's 2 cos, so that numerator there is the same as this one, so this product has to be the same as that. So we look and say, well, if we multiply these two, we will get 1 minus cos squared. That's the difference of 2 squared, so the product of these two is 1 minus cos squared, because the cos is cancelled out. And that gives me 2 cos theta over sine squared. Now, these two are the same. So take this one and put it down. Take that one, put it down right here. So that's 2 cos theta over sine times 1 over sine. And that's the same as 2 cot theta cosecant theta. And again, this is on a sheet of scrap paper, was underneath my fingers. So notice I worked it out. I got here and I noticed that sine squared was the same as 1 minus cos squared, so I changed it. And then from there, these two are the same here and here. So I took this step and moved it right there. And I took this step and moved it right there. And this makes sense. So if you multiply all this right here, you will get that. And so there it is. And that's, since the left side equals the right side, it is an identity. And again, this is what was underneath my fingers, is on a sheet of scrap paper that nobody sees. That brings us to the end of the unit proving identities in Trig. And if you like my unit and my videos, click on the like button, click on the subscribe, notification bell, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.